Hi guys, there's another question from section 3.1. This is number 33. So we have our function f of x. Let me write the function before I tell you the instruction, what we're supposed to do here. F of x is x squared plus 6x minus 3. Okay, so there are really a couple of questions here. Of course, when it comes to issue of relative max, relative mean, as I'm sure by now you know, you always have to look for the critical values, because if there is a maximum minimum, it has to happen at the critical values. So we always start, and of course critical values come from your derivative. So we're going to start with the derivative, which is 2x. By the way, you should know what this graph looks like, because I know at the end they want you to graph it. So this might be something you might remember from your college algebra. This is a quadratic function. Remember, this is a parabola, except they want us to use calculus here instead of algebra to get the graph very quickly. So again, to find the critical values, we're going to set the derivative equal to 0, as I was explaining last video. And then we're going to solve for x. So as the 6 goes there, become negative 6. And then to remove the 2, we divide by 2, which of course says x is negative 3. So the only critical value this function has is going to be negative 3. Now to find the relative max or relative mean, which is the next question. Also here, they want to know where the function is increasing, decreasing. Now remember, the sign of the derivative not only tells you where it's increasing, decreasing, but also determines the relative max or relative mean. Actually, in this case, there is only one critical value, so we don't need to split it exactly only at that value, which gives you two intervals, negative infinity to negative 3, and then negative 3 to infinity. So now we're just going to take a test value in each interval. So I'm going to go ahead and pick negative 4. I mean, it doesn't matter what value as long as it's there, but I'm sure negative 4 probably is the easiest value to the left of negative 3. So we evaluate and then observe the sign. So it's 2 times negative 4 plus 6, which is negative 8, plus 6, which of course is negative 2. Which means derivative is going to be negative over that entire interval. Now, test value on the next interval, negative 3 to infinity. Again, always take advantage of 0. If you can, use that as a test value, because 0 is very easy to compute with. Of course, 0 is there, so we can use 0 as our next test value. Again, as you plug in 0 in place of x, that becomes 6, which is positive. So that tells you your derivative is positive. So you already know where this function is increasing, where it's decreasing. I'm just going to make a note of that. I'm going to put I and C for increasing. Now, whenever derivative is positive, the function is increasing. So in this case, on this interval, the function will be increasing because the derivative is positive. So it's increasing on negative 3 to infinity, which, by the way, is going to help us in a minute when we graph it. Also, decreasing, I'm going to put DEC for abbreviation for decreasing. Onward derivative is negative. And of course, in this case, derivative is negative on the interval negative infinity to infinity. So actually, you have a pretty good idea what the picture looks like right now, because it's decreasing, which means it goes down, then it becomes increasing. So that gives you a relative minimum, by the way. So you do have a relative minimum at negative 3. So we'll find the exact, because we do have to graph it. So there it is. So now you know where the function is increasing, decreasing. We have the critical values. And the last step is to find the actual point where the x value of negative 3, and then we're ready to graph it, okay? So let me go ahead and see if I can do that right here. So again, we have all that fact already, so that should tell us pretty good. That should give us a good idea what the graph looks like. But first, let's find the exact relative minimum. So we know it's x value, negative 3. Again, don't forget to find the y value. We're going to plug in the negative 3 in place of the original function, because y is always f of x, which in this case, as you plug that in, that should give you basically negative 12. I'll let you plug that negative 3 in place of all your x's. Make sure you get that, okay? So there's your relative minimum. And you, by the way, you're not going to be shocked what the graph looks like, because remember, this is a quadratic function. So from algebra, you know it's a parabola, except now we're just using calculus. So I'm going to go ahead and graph it right here for you. So this is basically what the graph looks like. You don't have to show us a lot of points. Just give us the highlight. And the highlight here is your relative minimum. So I'm going to go ahead and see if I can squeeze the graph right here. So relative minimum happens when x is negative 3. Let's say here is negative 3. Y is negative 12. Let's say here is negative 12. And basically, you're just going to have, don't forget the graph is a relative minimum, which means it goes up on the left. And then, of course, it decreases on the left and increases on the right. Which, again, should be a no shocker to you, because that is exactly what the graph should be. It's a parabola, right? That's a quadratic function, except we use calculus to actually get the graph, okay? All right. So there are a couple more questions from section 3.2. I tried to see if I can upload these two on to 3.1 and then make those for 3.2, okay?